All right, stop this video right now and read on page 288, the section on connecting differential and integral calculus. Go, read it now. Okay, so who would have guessed that taking a derivative, finding the slope of a tangent line, could be connected to finding the area under a curve? But Newton and Leibniz, the fathers of calculus, they figured it out. Here is the secret. You can undo an integral with a derivative, and you can undo a derivative with an integral. So this is going to get formalized in section 5.4, but this is the key to all of the rest of calculus. You can evaluate a definite integral, not an approximation. You can get an exact answer for the value of a definite integral if you can find an antiderivative for the integrand. So this is the big deal. If capital F is any of the infinitely many antiderivatives of a function f, then the integral from a to b of little f is capital F of b minus capital F of a. So we're going to try this example. I have the integral from 0 to pi of sine of x. I need to think of a function that's an antiderivative for sine. So an antiderivative. What function could I take the derivative of and get sine as the answer? Well, is it cosine? What's the derivative of cosine? That's negative sine, so it's not quite right. Here, my antiderivative, I'm going to call it capital F of x. Capital F of x is negative cosine of x. It could be negative cosine of x plus 7, negative cosine of x minus 3, but I can use any antiderivative. I may as well just use the easy one. So, an a and b I can see in this problem are 0 and pi. My answer is going to be the opposite of the cosine of the top limit minus the opposite of the cosine of the bottom limit. Which, if you remember your trigonometry, the cosine of pi is -1, so this is -1, which is +1, minus, so plus. The cosine of 0 is 1, and I get my answer, which is 2. So the area under the sine curve between 0 and pi is 2. Okay, I have a similar problem here. This time my integrand is secant squared of x. Can I think of a function whose derivative is secant squared? Yeah, well, capital F in this case is going to be tangent of x. So this integral has a value of tangent of pi over 4 minus tangent of 0. Tangent pi over 4 is 1 minus tangent 0 is 0. My answer is 1. All right, so last example problem here. This is from the released multiple choice test. The integral from 1 to 2 of 4x cubed minus 6x. I can evaluate this integral if I can find an antiderivative for 4x cubed. Well, what would I take the derivative of to get 4x cubed? You can probably think of this. Capital F of x in this case is going to be x to the 4th, because the derivative would be 4x cubed, minus, and this would be 6x squared, so x squared, number 2, 3x squared. Because you could imagine taking the derivative in your head, the 2 would come down and multiply the 3 to make 6x. This is my antiderivative. So I could evaluate this integral by finding capital F of 2 and subtracting capital F of 1. So capital F of, and then subtracting what I get when I figure out capital F of 1. Most important idea, do not forget these parentheses or brackets. This subtraction has to get distributed, and they will catch you on that mistake every time you make it. So here we go. 2 to the 4th is 16 minus 3 times 4 is 12 minus, this is 1 minus 3. And I get 4 minus -2, which makes 6. Final answer is 6.